Hi students, നമ്മുടെ JEE NEET എക്സാം ഒക്കെ അടുത്ത് വരികയാണല്ലോ. ഫിസിക്സിൽ നന്നായി കൺസെപ്റ്റ് മനസ്സിലാക്കി ക്വസ്റ്റ്യൻസിനെ അപ്രോച്ച് ചെയ്ത് കഴിഞ്ഞാൽ നമുക്ക് വളരെ എളുപ്പത്തിൽ സ്കോർ ചെയ്യാൻ പറ്റാവുന്നതേ ഉള്ളൂ. നമുക്ക് ഒന്ന് രണ്ട് പ്രീവിയസ് ക്വസ്റ്റ്യൻസ് ഒന്ന് വർക്കൗട്ട് ചെയ്ത് നോക്കാം. ഓക്കെ, എ പാർട്ടിക്കിൾ ഓഫ് മാസ് m is dropped from height h. At the same time, another particle of same mass is thrown vertically upward with the speed root 2gh. If they collide head-on perfectly inelastically, then the time after which they reach ground in units of root of h by g is. Okay, we will solve it. Yes, there are two bodies A and B. A is dropped from rest. Okay, at the same time B is thrown vertically upward with the speed root 2gh. They collide from this position perfectly inelastically. Let A moves distance x, then B moves distance h minus x. Okay, in the case of A, u is 0. So in the equation s equal to ut plus half at square, u is 0. Therefore x equal this distance x equal to half gt square. In the case of B, it travels a distance h minus x for collision. The t is the time taken for the collision. Okay, in this case there is initial velocity. So s equal to ut minus half gt square. So the distance is h minus x. Half gt square is x. So substitute half gt square x. So minus x and x cancel. So t equal to h by u. In this case u is root 2gh. So on solving, t is equal to root of h by 2g. Okay. Then we are going to find the velocity at the time of collision. Okay. In the case of A, u is 0. So v equal to u plus at. U 0. So va, velocity of A equal to gt. Okay. In the case of, so substitute for time. Time we got as root of h by 2g. First case, time got as root of h by 2g. So substitute here the time. Then find the velocity of A. It will become root of gh by 2. In the case of B, the velocity of B at the time of collision. Here also we are applying v equal to u plus at. In the case of B, there is initial velocity root 2gh minus gt. Substitute the time for collision, root of h by 2g. On solving, this becomes like this. Okay, root 2gh, initial velocity root 2gh minus time, substitute the time. Okay, then it also become root of gh by 2. So velocity of A and velocity of B, velocity of A and velocity of B at the time of collision are equal. A and B have same velocity at the time of collision. Okay, so the velocity will cancel at the time of collision. Okay, so the combined mass, for the combined mass, the collision is perfectly inelastic. Okay, the combined mass is at height h minus x from the ground. So velocity of A and velocity of B at the time of collision are root of gh by 2 both. So they cancel each other. So the velocity of combined mass becomes 0 and it falls from height h minus x. Okay, then we want to find the combined mass, time taken by the combined mass to reach ground. Let the combined mass reach the ground in time t dash. Combined mass reach the ground in time t dash, but the combined mass falls from height h minus x. Okay, the collision is perfectly inelastic. So the both bodies stick together. Okay, and initial velocity becomes 0. So because at the time of collision the velocity cancels. Okay, so we are going to find h minus x. H minus x. X is half gt square. Substitute h minus x. X half gt square. First case. Okay, then this t is the time taken for collision. Okay, then substitute t square. T is root of h by 2g. Here t square, it will become t square h by 2g. So on solving this, it will become 3h by 4. So this h minus x is 3h by 4. The combined mass falls from height 3h by 4. And let the time taken by combined mass to reach ground is t dash. So again I am applying s equal to ut plus half at square. For the combined mass u0, it comes from height 3h by 4. So S 3h by 4. Ut, U0, Ut cancel. So half G T dash square. Now T dash is the time taken by combined mass to reach ground. Combined mass falling from height 3h by 4. H minus x, 3h by 4. So T dash square equal to 3h by 2g. T dash equal to root of 3h by 2g. So it becomes, the answer is root of 3 by 2 root of h by g. So root of 3 by 2 times root of 3 by 2 times root of h by g. That is the answer. So root 3 by 2 is our answer. Okay. Yes. A homogeneous solid cylindrical roller, okay, is pulled on a cricket pitch with a horizontal force, by a horizontal force. Okay. The rolling is without slipping. That is pure rolling motion. Okay. The angular acceleration alpha, angular acceleration of cylinder is, this is the question. Okay. A solid cylinder, it is pulled horizontally by a force F, capital F. Then on a cricket pitch, this is the friction, small f is the friction. We know that net force, resultant force equal Ma. Net force, these two forces are in opposite direction. So net force is F minus F equal Ma. On solving, A equal to F minus F by small m. Okay. We want to find the angular acceleration alpha. Suppose the torque about this axis of the cylinder, about the axis of the cylinder, the torque due to friction. Okay. About this axis applied force karanam torque undavilla. About this axis torque is happening due to friction. So torque due to friction, tau equal to Rf, Fr, F is friction, and also we know that tau equal to I alpha. So equating Fr and I alpha, okay, this is solid cylinder. Okay, this is the axis. The moment of inertia is mr square by 2, and also we know that A equal to R alpha. So alpha equal to A by R. Moment of inertia mr square by 2, alpha A by R. Okay. So on solving, friction equal to Ma by 2. Friction is Ma by 2. From this equation, take a friction right side. So applied capital F equal to small f plus Ma. We got friction as Ma by 2. So it become Ma by 2 plus Ma. So it is 3 Ma by 2. Okay. So from this, acceleration is 2f by 3m. Okay. Ready? So we want to find the angular acceleration alpha. Okay, alpha equal to A by R. From this, alpha equal to A by R. So in this denominator there is an R. So 2f by 3mr is the answer. Angular acceleration. Okay. അപ്പോൾ എല്ലാവരും maximum questions ഒക്കെ നന്നായി workout ചെയ്ത് ശീലിക്കുക. Okay, all the best. Thank you.